Hello everyone and welcome. My name's Costa and I'm a final year robotics engineering student, and my project for my honours thesis has been collaborative robots for the wine packaging environment. This project has been done for Treasury wine estates, and the entirety of the project has been done here on campus at Tonsley. My academic supervisor is NASA, and my industry supervisor has been Ms. Melissa Droge-Mueller. So currently, wine packaging, gift packaging of wine bottles is done at Penfolds manually by human operators, and this can be quite ergonomically challenging and repetitive. So this project investigated how using a collaborative robot for performing these tasks could be done and whether it would be a feasible option. So typically, this would affect any intricate packaging with wrapping, gift boxing, or labelling. So previously on campus, other collaborative robots have been used in projects for the tasks of snack packing or beer pouring, and these robots were perfect for the jobs as they didn't require guarding, as collaborative robots typically have safety systems and sensors in them which, if they bump into something, they'll stop and not destroy whatever they're, or damage or hurt whatever they're bumping into. So this project was split into 5 major milestones, each increasing in difficulty. And the Sawyer collaborative robot was chosen for service as it was readily available on campus, and its recent purchase and revival of its mother company, Rethink Robotics, by a German robotic and automation group, Home Group, meant that the service would be ongoing and any service would be provided any updates, so that was an extra incentive to use this robot for the project. So this was the project timeline, and it's quite descriptive. It's got every single task that I did on it, and because I did it like this, it allowed me to show what my actual progress was versus the planned progress, which helped in updating my stakeholders how I was going with my project and where I was currently at. So the project began in the first week of April with a kick-off meeting, and the development period, according to this, was finished in the 20th of September. So there were some associated risks with the project, and just quickly, it was injury by robot or injury by broken glass. And initially I did plan to update my project stakeholders and supervisors weekly. That did end up following through, so I was just updating whenever I had content to update on, and I was also making videos and putting them on YouTube just for ease of sharing what my progress was. So I was supplied with 3 bottles. In the project, I only ended up investigating how I could package 2 bottles, and I was also able to completely remove the risk of broken glass by catting up the bottles and 3D printing them. And furthermore, I wasn't actually able to test the bottles when full because any pouring of liquids in the lab downstairs is not allowed, so if a bottle was to break, that would have been pretty catastrophic. And so that's the bottles all catted up and printed, and I printed them in sections, not only because they wouldn't fit on the printer hole, but also because I guessed that some necks were going to break, and they did, so it was easy to reprint just the necks whenever that happened. So how I was going to design the gripping system initially, I was inspired by the gripper that the UR5 currently has. It's got a dual finger setup and they're actuated pneumatically, and so I was interested in designing some sort of system similar to that where the robot would have multiple sets of fingers on the gripper, so that would not require the robot to have gripper changes between operations or between single tasks in one operation. And so I was able to obtain some CAD models of the robot and its gripper, which allowed me to easily design fingers for the robots without having to travel to uni back and forth and perform measurements, and if I printed something then I'd have to correct it if there were mistakes and whatnot. And I designed many different fingers for many different positions on the gripper. We'll get a bit more into that soon. So my fingers were predominantly, or actually they were all prototyped using 3D printing, and the inaccuracies of 3D printing didn't really affect the project too much. Here and there the parts were only less than 1 millimeter out, and that didn't affect anything too much at all really. And so these were the fingers that I designed to grip both types of bottles that I worked with. And I initially was testing these fingers by just simple repetitive picking and placing tasks. And any accumulative errors from picking and placing the bottles would be corrected as when the fingers would grip the bottle would locate into the center, and that would remove the error completely. So like I said, I broke a few necks, many fingers as well, so I did spend a lot of time in this project printing. And so with my wine fingers developed and finished, I then set out to develop a set of fingers to handle the boxes, and the reason I was using Baxter is just because it was quicker to turn on to take this photo for. And from here I was still wanting to create a gripping system that could have multiple sets of fingers, and I thought, what if there was an easier way and a cheaper way to do this? So what I did was I designed a set of fingers that could both grip a box and a bottle, not at the same time separately, but that is what I came up with. So there were many different versions. All the blacked out versions I didn't print or didn't ever test. And eventually I came to a final version, which I was happy with, and I printed that off. It's got small convex structures on the surface to increase friction, as initially the box was slipping out of the fingers, so that helped with that a little bit. And an extra thing that I designed and made, not just the bottles and fingers, was a datum, as one time when I had the box sitting still and the robot was inserting a bottle, the bottleneck snapped because the box slipped, something happened, I don't know what it was, so I rectified anything that could happen there with a datum, so it wouldn't wobble. So with my process set up and planned out, I was able to start working. Also, I had all these models available, these CAD models, 3D models that I found and also made myself. If I had been using a more dangerous or more powerful industrial robot in this project, I would have investigated how I could simulate the process instead of just programming and testing, but that wasn't necessary for this project, so it wasn't investigated, but I could have done that if I wanted to go down that path. And if once again I was using a more dangerous or powerful robot, I would have done that as well before testing on a real robot. And so the second milestone of the project was very straightforward and simple to achieve. It just involved me testing my fingers and how I could package a bottle using them. So this video is sped up because the cycle time is quite high. So that's short and sweet, and that's what that does. So initially the cycle time once again was very high. It was 140 seconds. And typically the human operators, they can package a bottle in 2 seconds, like it doesn't take them really anything to do. And so shortening the cycle time was a high priority. So through optimizing the program by speeding up any moves, eliminating any unnecessary homing positions, I was able to reduce the runtime by 26% to 104 seconds. So the third milestone of the project involved me using vision, and the Sawyer robot has a camera built into its wrist, you call it, and I learnt a lot about how limited the camera is and the limitations that it has. It can't search an area for an object. All it can really do is take a photo of an object, store that in memory, and then in runtime it can move its arm to a position, take a photo of the object again, and then to a set threshold compare. So really all it can do is just perform inspections. But it does have some object tracking in frame. However, one annoying thing was if the cloud coverage would change just slightly, that would throw out the whole thing altogether. So I was constantly having to change the contrast, the exposure, and sometimes I was experimenting with the flash as well, but the reflection off the table and off the glass bottles just wasn't good. Also, if the object in frame is slightly covered by my hand or something, it just thinks it's lost it in sight completely. So with a giant program, I created this vision program, and what it does is it builds on from the previous program I had, where now it performs inspections to check that a box and a bottle are available and that everything that needs to be clear is clear. So this is quite sped up because it's a long video otherwise. So it does the inspections, and then it grabs the box and puts it into the datum, and you'll notice that this operation uses the dual finger setup. So I can perform this task without having to change the fingers in between. And so now it drops it off in a drop-off location, which I guess could represent a conveyor belt. So that would now take the packaged good away to be labelled and sent off to wherever it gets sent off to. And so this cycle time was not as long as the initial one that I had, and I was also able to reduce it again through the same methods to just over 113 seconds. So the fourth milestone of the project involved me packaging the bottle with respect to its label. So this particular bottle's box had a window, and I needed to package the bottle with the label facing out of the window. So once again, I created a new set of fingers. This time it would allow the robot to pick the bottle with its arm rotated vertically instead of horizontally, which meant that I had more room in the table as the arm wouldn't be taking up so much space, and also it allowed for some more precise picking and placing movements. So to tackle this challenge, I had two methods. The first one involved using repetitive checking and turning of the bottle, and the robot would do that itself. So it would check and turn and check and turn. So this could be quite slow if the bottle label was not visible at all for a few turns. So with this particular process, I was testing it with the same consistency each time, with the label starting in the same position to get my cycle times, which were, they're on the later slide. So the second method I investigated looking at was if I could get the bottle to be turned externally and not by the robot itself. So I designed this, I called it a turntable, I don't know if that's the right terminology, right name, and it was actuated by a continuous rotation servo motor, and I programmed that it was actuated, controlled by a Flinders. So there I am pushing a push button, which is to simulate the robot's digital output. So here we are, the robot arm just stays still and the bottle turns. Once it's seen the label, it can package it. And so this was much quicker than the previous method. And sometimes with that box lid, it wouldn't click shut. So that was just a small problem that I had. And so with this new and improved method, I was able to reduce the cycle time by, once again, quite a bit to 75 seconds for this bottle orientation milestone. And so next, I was interested in how I could create my own label recognition software, or rather my own feature extraction algorithm in MATLAB. And so I started with just a simple image of a rod or whatever that was that I drew up in Microsoft Paint, performed some edge detection, and then manipulated the RGB channels to show the edges over the original image. And also through some techniques that I learned taking the image processing topic and using some of the MATLAB built-in functions, I investigated some edge detection for the bottle, that's the bottle cap. So something I found that the canny edge detection algorithm was very good at picking up everything in frame, even blurred or shadowy details, it picked up everything. And that's not really what I wanted to do. So I investigated using some other filters like the Sobel or the Roberts, which were good at ignoring those finer details and just leaving me with what I wanted to know, which was what was right in front of the camera, so just the bottle itself. And so with some well-lit footage, I got this video, and why did that just do that? I'm not sure what's happening there. Okay, it's working now. So this is the bottle spinning, and that's what MATLAB's seeing. At the end of that function, it spits out a proposed frame where the label could be, just based on the pure fact that this is the frame that had the most features. I was then able to update this and use live footage with it. So this is it running in real time. So essentially, you just tap the space bar, which simulates, I guess, a robot signaling the program to start or something. And what's in that frame is what's going to be analysed. So bottle spins round, hit space to stop recording, and then once again it proposes, in this frame is where the most detail was found, so this could be the bottle label itself. So the final milestone of the project involved bottle detection within a set area. And I started working on this milestone with some simple shapes. So I was trying to find the center of those shapes, and how I could do that, I used some MATLAB functions, such as binarizing the image to a set threshold. So I'd have the RGB image, convert that to grayscale, and then binarize it. And so with an image with multiple shapes, I found it was working quite well. So then I thought I could try and classify the shapes. And I was doing that by classifying each, I was calling them a blob. The circles were classified by their perimeter, and every other shape was being classified by just simple area equations. So when adapting this for use with an image of a wine bottle, I found that if I just applied it straight away, it was trying to detect every single detail in the image, every single reflection, every bit of text, and that was just horrible because the process time was ridiculous and I didn't really get anything good out of running that. So once again, through some image processing techniques I learnt in the topic, I was able to filter the image using some filters that I learnt about, and remove the text, remove reflections, smooth out the image, make it very simplified for use by the program. And so with some bottles, that's what the program outputs. It proposes that there's a possible bottle in this location, just based purely off the fact that that's a circular object. And that's one of the limitations of this program. And so once again, I was able to adapt this for use with live footage. And so this was just on my bedroom floor. So sometimes the patterns on the carpet confuse the program, but the smoothing techniques that it uses were pretty good at ignoring that most of the time. Let's do this again. There we go. So it wasn't working too well right now, but in a second I turn the flash on and it's much better. There we go, detecting all the bottles. And it also displays their coordinates on the screen, which would be able to be given to the robot for use of where it would be able to pick up the bottle from in the detected area. And so this led to the final part of the milestone, which I haven't been able to complete yet. So with the given coordinates of a bottle and these newly designed fingers that would enable the robot to pick and place the bottle and boxes vertically once again, I aim to achieve this final complete milestone, and hopefully integrate my image processing program through the robotics operating system. And so obviously the project incurred some costs. I did almost 134 hours of 3D printing, and that's the full total of everything. So what did I learn from this project? Well, I learned a lot about vision systems, building upon what I learned in the image processing topic. I was also able to learn more about robotic programming and how the Sawyer robot and its proprietary program, Intero, works. I was able to learn a lot about its limitations as well. And what didn't I get to achieve? Well, I didn't get to achieve my multi-finger gripping system, but that's okay because I investigated using another method which was a good substitute. And as of yet, I still have not been able to integrate the vision processing program through the robotics operating system as I initially planned to. Another thing I would have liked to have done through the development of the project was some more testing with the image program, with the fingers and other designs I could have investigated. So future investment, obviously the final milestone needs to be completed, and I'd like to actually see this used in the manufacturing environment and how it could be possibly adopted, or the methods that I investigated used in the future. Thank you for listening, everyone. Are there any questions?
Do you have any questions?
Sure. Thank you. First of all, just a really nice project. And it's kind of, again, there's been a few projects today where people have clearly achieved quite a lot over the time, and it's just, it's really nice to see. The 3D printed bottle substitutes, were they made to be similar weight to the original bottles?
No, they weren't. Originally, I did plan to have a slot in them and I could just put weights into them.
Mm-hmm.
I didn't end up doing that, and so I was just left with using the very light 3D printed bottles.
Okay.
Yeah.
Did you think about things like just lading wood to make more representative and more durable bottle substitutes?
I did, but I don't have the skills to do that on my own, so I would have had to do that externally. But that was something I did consider.
Yep, that's right. Sorry, you thought about it, that's the main thing. So in your cycle times that are typically well over a minute, what's the main contributing to that long cycle time?
Just the speed of the robot, really. I was setting most of the moves at max speed.
Yep.
And it was still quite slow.
So what is its maximum kind of speed? Like how many
I think
centimeters per second, or
yeah, I think linear moves, which was the main move of the picking and placing, was I think 1600 millimeters per second in the rotation of the joint.
Okay.
And one thing I also considered in the project that using a robot that fast isn't really compliant with Australian standards, because also the robot is about this level, so it can contact my head, it can contact my ribs. So that's something else that I considered. So that would actually make the cycle time longer, if anything.
Yep. Okay. But it wasn't processing time or anything. It was just the mechanics of the robot. Was the okay? Interesting. The bottle detection. So you're doing it from above because that's where you had the camera in the wrist of the thing, presumably, right? Did you think about doing detection with side cameras or ultrasound or other?
No, I didn't consider ultrasound detection cameras. I pretty much, I just detected the bottle from above. I didn't consider doing it from the side, apart from the label recognition.
Yep, sure. Again, and these are questions I'm not saying that you ought to have done, because again, 18 units, there's only so much you can do, right?
Yeah.
But I wonder that the shape of the bottles actually possibly creates some interesting opportunities, because it's actually interesting when you show one of those above shots, you actually see the stealth element of the bottle insofar as the curve is reflecting light away to other places, but it actually means that you can have light come in from other places that could be giving you positioning information, actually, even just as you read the image in the camera, just based on what you can see reflected in it. And likewise, being able to do ultrasound with remote transducers versus receivers. I think it's just interesting things that might be possible to do.
Thanks.
That's right. Anyone else?
Could you just ask, is it fast enough to be usable?
Is it fast enough to be usable is a question that's been relayed.
I would say not this model, not the soy robot.
Yep.
Maybe newer collaborative robots that are out now that are faster and do have more intelligent vision systems, then absolutely, but not Sawyer.
Yep, sure.
Why vision? That's my question.
Over other sensors?
Over anything else that you could have used.
Right. Purely because I was just interested in learning about vision systems and how I could manipulate images, and that's just it really. No other reason.
Yeah, right.
Perfectly fine reason.
Thanks.
Costa, is there a requirement for this to be very quick? What is the the product speed or rate that they is that I don't know. I just want to have a chat with
Melissa didn't specify a cycle time. She just
these are kind of premium one, and you don't make too many of these.
Yes.
It's just that it needs to be done during the day. Doesn't need to be too quick. That's my question. Is there?
I'll need to clear that up with.
Imagine that again. You can amortize out some of it. The slow cycle times that you have at the moment tends to be amortized out. So it comes down to, can you save human time sufficient to make it worth putting in? This is really what it boils down to, whether they only have, during peak time, they don't have enough people to actually do the packing, or whether it's direct cost saving and reducing the number of personnel required.
The aim of the project isn't necessarily to reduce personnel; it's just to supplement.
That's right. I'm speaking logically from the things. I'm not accusing the company of trying to reduce things. In all likelihood, it'll be that they'll be flat out, and this lets them get more done and create more value for the same outlay that they're currently putting out now. But once you've got the multiple bottle detection on the table and multiple box detection, then you can say, right, you give it a crate of bottles, you give it a crate of empty boxes, and then you come back in 20 minutes' time, and they're all done. That to me, I think, is where the low-hanging fruit, that will be easier to do than to get the cycle time down to 3 seconds to compete with a person.
Thank you.
Thank you.